These men are in the process of increasing their plant's efficiency, and at the same time, they're making this area a better place to work. This is thermal insulation. It's used on many of the systems in the plant. Basically, thermal insulation is anything that blocks the flow of heat. High temperature insulation prevents burns and keeps work areas from getting too hot. On cold piping, sweating and freezing is prevented by low temperature insulation. And just like in your home, insulation in the plant saves money by making heating and cooling more efficient. Today we're going to be talking about how thermal insulation is used in industry. This means that we're primarily concerned with large-scale systems and the piping associated with these systems. Now, part of your job as a maintenance mechanic is the upkeep of insulation systems in the plant. We'll be talking about installation and maintenance of the four most common kinds of insulation: calcium silicate, fiberglass, cellular rubber, and reflective insulation. But before we begin our discussion of the different types of insulation, let's look more closely at the job thermal insulation is supposed to do. Thermal insulation is intended to do one thing: prevent the movement of heat. Now, in some cases, we're trying to keep things hot. We don't want heat to escape. Other times, we want to keep things cold. We're trying to keep heat from getting in. To see how thermal insulation does this job, we'll have to take a look at how heat is transferred between objects. Now, there are three ways heat can be transferred. There's radiation, conduction, and convection. Let's take these one at a time. Radiation is the first kind of heat transfer. The fiery furnace of the sun burns at a temperature of millions of degrees. This heat energy is beamed out in all directions, or radiated. When the radiation is intercepted by a solid body, like the Earth, that body heats up. Now, here's an example of radiant heat that's a little more down to earth. When a piece of bread is toasted by the heat energy of the glowing coils in your toaster, that's radiation. Conduction is the second kind of heat transfer. Conduction is how heat is transferred through solid objects. When one portion of a solid object is heated, that area contains more energy than other colder parts of the material. To even out the distribution of heat, energy is transferred to the relatively colder areas. If the object continues to be heated, a constant flow of heat takes place from the hotter to the colder parts of the material. Convection is the third and last type of heat transfer we'll discuss. Convection refers to the movement of heat through a fluid, like air or water. When air travels over a hot object, it picks up the heat and carries it along. A constant flow of air cools the heat source as it distributes heat to other areas. In a closed space, the natural convection flow of heat causes a circular air current as the hotter air rises. These three kinds of heat flow, radiation, conduction, and convection, describe the ways that heat can be transferred between objects. Radiation is how heat is transferred across empty space. Conduction is how heat is transferred through solid objects. And convection is the circulatory motion of heat in liquids and gases. Thermal insulation is designed to prevent radiation, conduction, and convection of heat. There are two ways to do this. First, radiant heat losses can be prevented by reflecting heat waves back to their source. The kind of insulation that does this is called reflective insulation. Second, conduction and convection can be prevented by surrounding the heat source with a material that doesn't conduct heat and seals off the source from air currents that cause convective losses. Materials that do this are called mass-type insulation. These two types of insulation, reflective and mass-type, are our tools for controlling and limiting heat flows. Reflective insulation consists of a shiny surface that reflects heat like a mirror reflects light. Sometimes thin metal foils are used. In other applications, layers of reflective metal work together to provide a greater insulating capability. Or reflective insulation can be used along with mass type for the maximum protection from heat losses. Mass type insulation prevents two kinds of heat transfer: conductive and convective. First, the material must be a poor conductor of heat. Different types of materials vary according to how well they conduct heat. Metals are relatively good conductors, as you know if you've ever tried to grab a hot skillet. On the other hand, wood and fibrous materials conduct heat poorly. That's because they contain dead air, air that's trapped within the material in small pockets. Air is a good insulator, but only if convective heat losses can be avoided. Dead air prevents convective losses because air that's trapped within the material cannot circulate and give off heat to the surrounding area. Mass-type insulation combines these two elements into one: a material that's a relatively poor conductor of heat and dead air trapped in pockets within the material. The effectiveness of mass-type insulation depends largely on the amount of air trapped in the material. If the insulation is compressed, some of the air is forced out, reducing its insulation value. The same thing happens if the insulation gets wet. The effectiveness of mass-type insulation depends on the amount of air trapped in the material. In a few minutes, we'll see how insulation is used on the job. We'll be talking about reflective insulation and three kinds of mass-type insulation that are commonly used on piping systems. But before we go on, let's take a minute to review what we've learned so far. First, we learned that insulation is a material that blocks the flow of heat. Second, we learned three important reasons for insulating: to protect workers from burns and high temperatures in work areas, to keep water vapor from condensing and freezing on cold piping, and to save money by making heating and cooling systems more efficient. To learn how thermal insulation works, we discussed the three ways that heat is transferred: radiation, conduction, and convection. We saw examples of two kinds of thermal insulation: reflective and mass type.